Alright, we're going to talk about special angle pairs today. First thing we're reading about is perpendicular lines. And one of the most common things I hear from students when I ask what's a perpendicular line is they tell me intersect. That they intersect. And I think that goes back to when you first learned parallel and perpendicular. Parallel are the lines that don't intersect. And so you just saw perpendicular lines as the ones that do intersect. But most lines that intersect are not perpendicular. There's something very specific that happens where they intersect. Perpendicular lines are lines that intersect to form four right angles. When lines intersect and they form nothing but right angles, those are perpendicular lines. So if you don't have right angles, you don't have perpendicular lines. So if I draw this line and this line, if they're going to be perpendicular, then this angle should be a right angle, this angle should be a right angle, this one should be right, and this one should be right. They form four right angles. And the symbol for perpendicular is this symbol right here. It looks like an upside down capital T. But you should notice it looks like this is vertical and this is horizontal. It looks like they would form a right angle. That's the symbol for perpendicular. Okay. Alright, on example 1 it says line NP and line QR are perpendicular lines intersecting at point O. Find the value of x. Well, the second that I read that these two lines are perpendicular, I know that any angles that they are creating are 90-degree angles, right angles. So right here, I know this is a right angle. Well, it's labeled as 5x minus 5, so what that tells me is 5x minus 5 equals 90. Because right angles are 90 degrees. So then I can solve for x. I add the 5. And then I divide off this 5. And find out x has to be 19. X has to be 19 because that's the only way this angle will come out to be a right angle. And it has to be a right angle because the lines are perpendicular. Okay, a couple more vocabulary words. Supplementary angles are two angles whose measures have a sum of 180 degrees. So they add up to 180 degrees together. So if you just got one angle that's 180 degrees, that's a straight angle. Supplementary angles are when you have two angles and they add up to 180 degrees. Complementary angles are two angles whose measures have a sum of 90 degrees. So complementary angles add up to 90 degrees. So let's take that information. Try to do example 2. It says if angle 1 and angle 2 are complements. Now when it says that the two angles are complements, that means that they are complementary angles. So I know right now angle 1 and angle 2 are going to have a sum of 90 degrees. They're going to add up to 90. Okay, the measure of angle 1 is equal to 2x plus 20. Measure of angle 2 is equal to 3x plus 15. We want to find the value of x. Well, like we just said, because they're complements, because they're complementary angles, I know that they add up to 90 degrees. So I'm going to take angle 1 and angle 2. And I'm going to add them together because I know if I add them together, it will equal 90. It will equal 90 degrees because they are complementary angles. They're complements of each other. So there's the equation we can use to solve for x. So I combine like terms. I got 2x's, 3x's. That's a total of 5x's. Got 20 and 15. That's a total of 35. Just combining like terms. Now we want to get x all by itself. Move the constant first. It was being added, so we subtract, which is the opposite operation. And then divide off the 5. And there's x. Alright, adjacent angles. Adjacent angles are angles that have a common vertex and side, but no common interior points. So an example, if I have this angle, an angle that would be adjacent to it would be this angle. So notice that this angle has this vertex, and this angle has the same vertex. They have a common vertex, and they have a common side. This ray is the side for this angle, and it's a side for this angle over here. But they have no common interior points. The interior of this angle is right here in orange, and the interior of this angle is here in blue. There is not a single point that is in the interior of both of these angles at the same time. So this is an example of adjacent angles. Okay, when two lines intersect, they form four angles that have special relationships. So this is if you just got two straight lines intersecting each other. Notice it creates these four angles here. And we're going to learn about some angle pair relationships that are happening in the situations. Linear pairs are adjacent angles whose non-common sides are opposite rays. So one example of a linear pair is angle 1 and angle 2. Okay, if I look at angle 1 and angle 2, just focus on angle 1 and angle 2. Okay, they're adjacent. They have the same vertex, and they're sharing this side. So they have a common vertex and a common side. And their non-common sides are opposite rays. So this is the common side. These are the sides that are unique to each angle that they're not sharing. And notice they're opposite rays. So remember, opposite rays create a line, create a straight angle, which is how many degrees? 180 degrees. So a linear pair, the two angles in a linear pair are always supplementary. Those two angles, angle 1 and angle 2, are going to add up to 180 degrees. Because you got a straight angle being split into two smaller parts. Remember your angle addition postulate. These two parts have to add up to equal that whole, that straight angle of 180 degrees. Linear pairs are always supplementary. Now angle 1 and angle 2 are not the only linear pair in that picture. We also have angle 2 and angle 3. And you can see angle 2 and angle 3 are a linear pair right there. We also have angle 3 and angle 4. And I'm just rotating the paper around. Each pair of adjacent angles at an intersection of two lines is going to be a linear pair. And then we also have angle 4 and angle 1. Angle 4 and angle 1, also a linear pair. Okay, vertical angles. Be very careful with vertical angles. Most of the time we can kind of take the meaning of words and apply it in different scenarios. If you start thinking vertical, like straight up and down, you're going to throw yourself off because it really has nothing to do with that. Vertical angles are two non-adjacent angles formed by two intersecting lines. So the adjacent angles are the ones that are right next to each other, sharing a side. Vertical angles are the ones that are across from each other at the intersection. So while they're sharing a vertex, they're not sharing a side. Angle 1 and angle 3 are vertical angles. Angle 1 is using these two sides. Angle 3 is using these two sides. So they're not sharing a side, so they're not adjacent angles. They're non-adjacent. So angle 1 and angle 3 is a pair of vertical angles. And the other pair of vertical angles, angle 2 and angle 4. Angle 2 and angle 4 are also vertical angles. Now the vertical angles theorem tells us that vertical angles are always congruent. And just think about this for a second. If I have these two pins, or my two lines, and they're making an angle here and an angle here. If I make this angle smaller, watch what happens to this angle. So I'm going to make this angle smaller. And you'll see that as I make this angle smaller, this angle gets smaller as well. Okay, if I make this angle bigger, as I make that angle bigger, this angle gets bigger. So vertical angles always stay congruent to each other. Vertical angles are always congruent. They always have the same measure. Alright, let's look at this next example. Line AC and line DE intersect at B. Find the measure of angle DBC, so this angle right here, and the measure of angle EBC, right here. Alright, so let's find the measure of angle DBC. Here's angle DBC. Now we've only got one angle to work with. They gave us that angle ABE is 93 degrees. What relationship do these two angles have to each other? Those are vertical angles, right? We learned just a moment ago that vertical angles are always congruent. So if that's 93 degrees, then angle DBC is also 93 degrees. Now we also want to find the measure of angle EBC. We want to find this angle right here. Okay, now we don't have its vertical angle. It would be congruent to this angle over here, but we don't know what that one is. But these two angles are a linear pair. Okay, remember those adjacent angles, when you got two lines intersect, the adjacent angles are a linear pair, and they add up to 180 degrees. Remember, they're supplementary. So I know that this angle, whatever it is, plus 93 degrees has to equal 180. So to solve for x, I subtract 93. I should get 87. I know that angle EBC is 87 degrees. Oh, forgot to put the measure earlier. The measure of angle EBC is 87 degrees. Okay, let's check example 4. Line GH and line JK intersect at I. So we got two lines intersecting. So that's when we create vertical angles and linear pairs. Find the value of x and the measure of angle GIH. We want to know what this angle is. So first, we have expressions for angle GIJ and KIH. And you should recognize that those are vertical angles. And we learned vertical angles are congruent. Congruent means equal measures. So anytime we have things that are congruent, we set them equal to each other. So I know that 16x minus 20 is equal to the same thing that 13x plus 7 is equal to. So we set them equal to each other, and we can find out what x is by solving this equation. So I'm going to subtract off the 13x from both sides. I want to get x by itself. I'm going to add 20, get rid of the constant, and then divide by 3. And that tells me x is 9. So that's part of our answer. We were told to find the value of x, so that's part of our answer. And the other thing we're supposed to do is find the measure of angle JIH. Now, I do not have an expression to substitute that number into to get angle JIH right now. But what I can do is notice that angle JIH is a linear pair with that angle right there. It's also a linear pair with this angle right here. So either way, I can know that it's going to add with one of those angles to equal 180 degrees. So you're going to have a sum of 180. So what I need to do is find one of those angles, and I can proceed from there. So if I take the 13x plus 7, and take this 13x plus 7, and substitute 9 in for x, we just found out x was 9. Okay, I got 13 times 9 is 117, plus 7 is 124. So I know this angle is 124 degrees. And since these are vertical angles, they're congruent. Either one of these angles is 124 degrees, right? Now remember, these are supplementary. They're a linear pair. They add up to 180. So whatever this angle is, plus 124 equals 180. So I can subtract 124 from 180. And that tells me that angle JIH is 56 degrees. The measure of angle JIH is equal to 56 degrees. Okay, example 5. Line LN and OP intersect at M. Find the value of x and the measure of angle LMO. We want to find this angle. And the measure of angle OMN, this angle. Alright, so first step, got to have an equation to solve for x. I see expressions on angle OMN and LMO, both of those expressions. So what relationship do they have to each other? That is a linear pair. They are supplementary. So I know that they add up to 180. So that's exactly how I set up the equation. I'm going to add them together, set it equal to 180. Okay, so we're solving the equation. We've got to combine like terms. I got 5 x's, 7 more x's. That's 12 x's. Then I have 10 and 20 is 30. I want to get x by itself. I'm going to move the constant. It was being added, so I'm going to do the opposite and subtract. And then x is being multiplied by 12, so divide by 12. Alright, now it said find the value of x. We did that. That's part of our answer. Now we need to find the measure of angle LMO. Angle LMO, they gave us an expression for this one. It's 7x plus 20. So I'm taking that 7x plus 20 and I'm substituting 12.5 in place of x. And if I do 7 times 12.5 and add 20, we find out that the measure of angle LMO is equal to 107.5 degrees. Then we also are supposed to find the measure of angle OMN. Angle OMN is the 5x plus 10. It's the exact same process. I'm just taking that expression and I'm substituting 12.5 in for x. And if I do 5 times 12.5 and add 10, I find the measure of angle OMN is 72.5 degrees. And you can check yourself when you're done. Remember, they're supposed to be supplementary. They're supposed to add up to 180. If I add those two numbers together, I will get 180. So I feel pretty good, pretty confident that I did everything correctly. If they don't add up to 180, you want to go back and recheck your work. All right, last page, guys. Example 6, find all the missing angles. Now, we can do this in a lot of different orders, okay? But let's just start with the vertical angles. Vertical angles should be fairly simple. Now, the one thing you got to be careful about here is we have more than two angles and two lines intersecting here. So you got to focus on the angles created by the same two lines that are vertical. So this 110 degree angle is formed by this line and this line. The angle that's right across from it, formed by the same two lines, is angle 2. Those are vertical angles. They should be congruent to each other. So if that's 110, angle 2 is 110 degrees. Okay, what about the 45 degree angle? The 45 degree angle is created by this line and this line. What angle is created by the same two lines right across from it? Angle 3. So these are vertical angles, so they are congruent. So angle 3 should be 45 degrees. Now you got a few different ways you can go about finding angle 1 and angle 4, but notice angle 1 is created by these two lines, and angle 4 are right across from each other, created by the same two lines. Those are vertical angles. So as soon as I find one of them, I'll know exactly what the other one is, because angle 1 and angle 4 are going to be congruent to each other. Now how do I find what one of them is? Well, remember, a straight line, a straight angle is 180 degrees. Now, notice that this straight line, this straight angle of 180 degrees is split into 3 parts. But those 3 parts should add up to equal the whole. Those should add up to 180. So you got 110 and you got 45. That's 155 degrees. And all 3 should add up to 180. So subtract the 155 from 180 and you should get 25. This has to be 25 degrees so that you'll have that 180 degrees there in that straight angle. So I know angle 1 is 25 degrees, and therefore, vertical angles being congruent, I know that angle 4 also is 25 degrees. All right, last problem, guys. It says line CD is perpendicular to line AB. Make sure we remember this symbol means perpendicular. And remember, perpendicular means that where they intersect, they're going to create right angles. So line CD and line AB perpendicular. So this is a right angle and this is a right angle. Now measure of angle 1 is 6x minus 3 degrees. And measure of angle 2 is 7x minus 11 degrees. Find the value of x. Okay, if I just focus on this part of the picture, remember line CD and line AB were perpendicular. This is a right angle. That right angle is being split into 2 smaller angles. Remember, angle addition postulate, the 2 parts have to add up to equal the whole. And so these 2 angles should be adding up to equal 90. So that makes them complementary angles. Remember, complementary means they have a sum of 90. So I'm going to set my equation up just like it sounds. These 2 parts should add up to equal the whole, which is a 90-degree angle. So they're going to add up to equal 90. They're complementary. They have a sum of 90. We're adding them together, set it equal to 90. So now we combine like terms. We got 7 and 6 x's. That's a total of 13 x's. Negative 11 minus 3, that's negative 14. Keep solving for x. We got to get rid of the constant to try to get x by itself. And then x is being multiplied by 13, so we divide by 13. And you should get x is 8.